Hi guys, welcome back to my channel, Math in Minutes. So today we're going to be doing something a little different today. What we usually do is we usually do algebra, right? So this time we're going to be doing geometry, and this is just the basics of perimeter, area, surface area, and volume. So when is geometry used? Well, geometry is mainly used in architecture and design, engineering, and mainly in the technology and designing field. For example, here are some examples here that where geometry is used. So for example, in this case, the Parthenon, they're using the golden ratio proportion to probably measure out the spaces and the proportion of all of these pillars. And this one, I think they're trying to find the area of the curve for this bridge and to see it matches like with the other curves. And geometry is also used in cameras, mainly for this part, technology and innovation, such as AutoCAD, Canon, like those types of cameras. So we know that for perimeter and circumference, this is the total distance measure around a flat shape. So basically, we're just adding all the side lengths of the shape. In area, this is the amount of flat surface a space can be covered by a shape. So, and basically I think we all know what area is. It's just S times S, which is also known as S squared. And finally, we have surface area and volume. The surface area is the total area of all exterior faces. So for example, we already know the area of a square, which is S squared. And we have 6 faces in a cube, so that would be 6S squared. And then volume is the physical space occupied inside. So this is how much like a quantity can fit inside the surface area, like in the shape. So this is the golden rule of area. Most common pitfall in geometry is confusing a slanted side for the height. The rule is that the base, which is annotated as B, and the height, which is also annotated in H, must always form a 90-degree angle together, or otherwise known to be perpendicular. Even the height must be drawn outside the shape itself, which is mainly common for triangles. So there are some other mistakes here. Some people may confuse perimeter and area and volume and surface area. So we have to remember what the formulas are for perimeter, area, volume, and surface area. Other things are that people can also get the errors of the units wrong. So for example, perimeter is in units, area is in square units, volume is in cubic units, and surface area is in square units. This also happens a lot of the time too, is that some people can also apply the wrong formula for a specific shape. So for example, in a triangle, let's say that someone uses the area for the rectangle, which is length times width, and the correct formula for a triangle is 1/2 of base times height. So this is like a formula sheet for most of the common shapes of their formulas for area and perimeter. I'm pretty sure we know what these two are, but these are really easy. And for parallelogram, it's also the same thing as these two. For triangle, their area is 1/2 of base times height, and their perimeter is just the sum of their exterior sides. For trapezoid, it's a half of the height times base 1 and base 2. And the perimeter is also the same. You just add all the exterior sides together. Now, I think most of us know what the area of this is, which is pi r squared. And for its perimeter, it's just the circumference, which is 2 pi r, because the circumference is equal, basically like the perimeter of the circle. Or it could also be c equals pi times the diameter, which both of them work. So in the circle, we have a diameter, which is annotated as d. We have the radius, which is a r, and we have the circumference, which is in c. So the radius is half the diameter, because if we bring this arrow down, the radius arrow down, we can see that it's half the diameter. So for example, we had a diameter which is 4, and we just discussed about these two. And we mainly use pi in circles. So pi is an irrational number in a non-terminating decimal, so it just keeps on going forever. The short form for pi is 3.14, but we mainly keep it as a simplified version as pi. And this is basically just a universal constant representing the ratio of any circle's circumference to its center. So we have irregular polygons here. I think most people get them on like tests and all that. So basically, this is what an irregular polygon looks like. And what we can do is we can split it into two polygons, two shapes basically. So in this case, we can just draw a straight line here and we'll get two rectangles. And we need to remember the singular formula that exists for irregular shapes because you always need to use two separate formulas together. So this is the method right here. So basically we slice the complex polygon into two shapes. Rectangles or triangles are the most common. We calculate the area of each individual shape and then we add them together. And that's how we find the total area of this irregular polygon. So we're going to be learning about surface area now. And what surface area is just the total sum of all the exterior areas of all 2D faces on a 3D object. And what is most helpful in surface area is in that we can visualize a 3D shape being flattened and being shown as like a diagram. And we can like visualize as like an origami thing, like of how we fold it. So we have the map of a rectangular prism. We can visualize it like this, find its area, and add it all together. Now we have the surface area of a rectangular prism. Its surface area's formula is 2 times length times width, plus 2 times length times height, plus 2 times width times height. And these are 3 pairs of identical rectangles, as we can see here. And there's one big rectangle in the center. And we have the surface area of a cube. This one's really easy to remember because all the squares are identical. So its formula is 6s squared. So this is surface area, which equals base times height plus a times w plus base times width times c times w. So we don't know what a and c are. They can be anything. And here we have two of these triangular faces, three rectangular sides, and yeah, that's how triangular prism works. And now so in volume, this just measures the capacity of an object. So it's like kind of like a storage unit of like how much it can capacitate. And it's fundamentally written as length times width times height. So this is the length, how long it is, the width, how big it is, and the height of like how long it is like vertically. So the formula for this is length times width times height. And for the cube, it's s cubed because all sides of a square are equal. Now this is just a little cheat sheet to remember all the formulas for the basic shapes and their surface areas. These are the most, and here we see these are the most common formulas used for each shape. So in square and rectangle, area and perimeter are used. This one only has area. This one also has area. The trapezoid has both area and perimeter. Circle has both area and circumference. Cube has a volume and surface area. And rectangular prism also has volume and surface area. And that's it for today.